Welcome, Prep 1, to our science session today. Unit 1, Lesson 3, about the atomic structure of matter. As you know, the matter around us may be solid or liquid or gas. Any one of them consists of molecules, and the molecules consist of a smaller one, we call it atoms. So what's meant by the atom? Atom is the fundamental building unit of matter, or it is the smallest individual unit of matter that can share in a chemical reaction. Before we start this part, we have to know the symbol of elements. Like, for example, hydrogen, the first letter is H, so the symbol of hydrogen is H. While helium, the first letter and the second letter, He. But it's very important to differentiate between them. If we have only one letter, write it in capital letter. 2, the first capital and the second small letter. Like, for example, here, carbon, Ca, while sodium, Na. You can find in this part here, sodium, we use the Latin name Na, while potassium, K, while copper, Cu. Now, what inside the atom? The scientists study what inside the atom. It's nearly like the solar system. The solar system consists of sun in the middle, which surrounded the 8 planets. Here, nearly the same. The atom inside it, the very, very important part in the middle of the atom, we call it a nucleus. This nucleus contains 2 parts or 2 particles. Number 1, protons that carry the positive charge, and the neutrons carry neutral charge, or we call it electrically neutral particles. Around the nucleus you can find electrons. Electrons are negative charged particles that rotate around the nucleus in a very, very, very high speed. If we look at all the atom, we can find the mass of all the atom concentrated inside the nucleus. Why concentrated inside the nucleus? Because the mass of the electrons, which outside it is or can be neglected if you compare the mass of electrons to the mass of protons or neutrons. So it's very, very small mass related to the protons or neutrons. Here the comparison between protons, neutrons and electrons according to the position. Protons and inside the nucleus, while neutrons also inside the nucleus, electrons around the nucleus and energy levels, or we call it shells or orbits. The charge of protons positive, the charge of neutrons, we call it neutral or not charged particles, the electrons negative charge. The mass, the protons have high mass, and also the neutrons have high mass if you compare the mass of them with the electrons, and the electrons have, or the mass of electrons can be neglected. Now go to the second part. We want to differentiate between 2 very important parts here, the mass number and the atomic number. The scientists count the protons and the neutrons inside the atom. The positive protons and the negative electrons, they are the same. Any one of them we call it the atomic number. So, as you can see here, the atomic number means it is the number of positive protons inside the nucleus. Also, we have another one, we call it mass number. We said that the nucleus of the atom contains the protons and the neutrons. If you count them together, protons and the neutrons, we call them the mass number. So, mass number, it is the sum of number of neutrons and protons that inside the nucleus of the atom. So as you can see here, again the atomic number is the number of protons or number of electrons, because they are the same. So in one of them we call it atomic number, while the mass number, it is the number of protons and the number of neutrons. So the mass number is bigger than the atomic number. Mass number is the protons and neutrons, while atomic number protons only. If you want to calculate the number of neutrons, as you can see here, equal mass number minus atomic number. Now go to the second part. We said the electrons around the nucleus, which rotate around it in high speed. Where? They rotate around the nucleus in high speed in imaginary regions. Okay, we call them energy levels or orbits or shells. There are 7 energy levels, as you can see here: K, L, M, N, O, P, and Q. Anyone have a specific number of electrons, but if each electron rotates around the nucleus its original energy level, we call it the atom. In this case, we call it a ground state. But sometimes some electrons gain more energy, maybe light energy or heat energy, maybe the atom itself subjected to heat or light, so the electrons inside it gain this energy. This energy we call it a quantum. So when an electron gain a quantum of energy, it's already jump or move to higher energy level. Stay there for a time, then move back to original energy level. So now we have 2 definitions or 2 concepts. One of them we call it a quantum, and the other one we call it excited atom. What's mean by a quantum? A quantum is the amount of energy lost or gained by electron when it transfers from one energy level to another. Means when an electron rotates on its original place, gain amount of energy, it's move or jump to higher energy level. The amount of energy that gain, we call it a quantum. Stay there for a time and move back. Then also lose the quantum again and return back. What's mean by excited atom? When the atom, as you can see here, it is the atom that gains a quantum of energy. So when an electron gains amount of energy or a quantum of energy and jump to higher energy level, in this case we call the atom, we call it excited atom. Means one of the electrons, one or more electrons, it is not in its original place. Stay for a time and return back to the ground state again. But how many electrons in each energy level? The number of electrons in each energy level is controlled by a rule we call it 2n power 2. What's mean by 2n power 2? It's the rule that controls the amount of electrons or the number of electrons in each energy level, while n is the number of energy levels itself. Like for example, K carry 2 electrons and L carry 8 and M carry 18 and N carry 32 electrons. If we apply the rule as you can see here, number 1, the first energy level K, we put this is 2 and N here, number 1 power 2. 1 power 2 equals 1 times 2 carry 2 electrons. So K carry 2 electrons. The second energy level L, we put here N power 2, 2N power 2. We remove N and put 2. So 2 power 2 equals 4. 4 times 2 equals 8. And we apply it in M and N. So you can see here, the first energy level K carry 2 electrons, and the second one L carry 8 electrons, the third one M 18 electrons, and the fourth one N carry 32 electrons. But it's very important that we cannot apply it more than 4. The 2n power 2, we apply it till n only, till the 4th energy level only. Why? Because if we put more than 32 electrons in energy level, in any energy level, the atom will be unstable. As you can see here, the rule works only with the first 4 energy levels. Why? Because the atom will be unstable if we put more than 32 electrons. Now go to the next part. Active and inactive. If the outermost energy level means the last energy level is completely filled with 8 electrons, okay, this element we call it inactive. This inactive element, the outermost energy level is completely filled with 8. Means this atom cannot lose or gain or share electrons. Why? Because already the outermost energy level is filled. So no need to lose or gain. While other one we call it active. Active means won't make activity means lose electrons, gain electrons, share electrons. Why? To complete the outermost energy level. Means active here, the outermost energy level not filled with electrons. So they lose or gain or share share electrons with other active elements to be inactive. So we differentiate between them here. One of them active, the outermost energy level cannot filled or not filled, while the inactive is completely filled with 8 electrons. We have example here, Na and Ar. Na, which sodium 11,281. The outermost energy level 1, so lose it, means share in a chemical reaction. While Ar, argon 18,288. 8, the outermost energy level is completely filled, means this atom here, we call it inactive. Because cannot lose or share or gain because the outermost energy level is completely filled with 8 electrons. Thanks a lot and see you the next session inshallah.